Good morning, everyone. Myself, Dinesh Meena. I am research scholar from Netaji Subhash University of Technology, Department of Civil Engineering, New Delhi. Today, I am going to present my work investigating the effect of varied recycled asphalt pavement content on marshal strength through sensitivity analysis. Under the guidance of Dr. Aswati Remo, Assistant Professor, Department of Civil Engineering, Netaji Subhash University of Technology, New Delhi. Outline of the presentation. Let us coming to introduction. Recycled asphalt pavement stands out as an environmentally friendly material comprising high quality aggregates coated in asphalt cement. When appropriately crushed and sieved, wrap emerges as a cost effective substitute for conventional raw materials, substantially diminishing the reliance on preciser vegan binder and aggregate in asphalt mixture. However, the integration of additional recycled asphalt pavement into asphalt mixtures presents a central challenge related to potential fluctuations in aggregate packing, leading to variations in the void mineral aggregate VMA. Objectives. This work offers a thorough analysis of how different recycled asphalt pavement concentration levels affect the strength properties of asphalt mixtures. Isolating the recycled asphalt content at, has the main variable of interest. A localized sensitivity analysis technique was employed to provide a thorough understanding of how rap content affects asphalt pixel performance. Then, literature review part, in which estimation of the optimum binder content of recycled asphalt incorporating a wax warm additive using a response surface method. In this paper, adopted in methodology, preparation of the materials, fractionation of recycled asphalt aggregate, preparation of the WMA additives and asphalt binder, phase second in which development of the experimental design, identification of main variable and responses. Experimental design using the RSM laboratory tests in which find the research gap based on the findings from the optimization, a comprehensive study on other types of aggregate. Binder and WMA additives will be proposed for model generalization. Global sensitivity analysis in stability problems of steel frame structures, in which adopted methodology initial imperfection, computational model, sensitivity analysis. In this applies to the imperfection of cross beam, the variability of which does not influence the load carrying capacity and can be considered in the stochastic model as deterministic. Response surface based approach to quantify variability in recycled asphalt concrete mixture. In the major steps were identifying input parameters that influence the mechanical and volumetric properties and their appropriate limits. Using the DOE approach, preparing of BC specimen and testing their mechanical and volumetric properties using generated testing metrics. Developing RSMs, conducting a sensitivity analysis. In this, the effectiveness of the study could be checked using more simulations. In addition, the long-term performance parameters of the RAP mixture were not considered in this study. These parameters could be explored in the future research. Then achieving the desired volumetrics and performance of mixture with high percentage of recycled asphalt pavement in which adopted methodology processing of wrap material, design of asphalt mixture, moisture acceptability test, complex modulus test, wheel tracking test. On the basis of the findings of this study, it can be concluded with confidence that it is possible to design high quality asphalt mixture with a high rep that meets the desired volumetric and performance. Then methodology adopted in which preparation of the Marshall specimen for varying rep content, obtain Marshall strength, then local sensitivity analysis to determine effect of rep content of mixture performance. Then plot graph between the recycled asphalt pavement content versus Marshall stability and rep content versus flow. Then obtain the optimum rep content. Result and discussion in which graph shows initially it was noted that with an increase in rep content, the Marshall stability also increased until it reached a peak value of 17.6 kilonewton. However, beyond this point, the Marshall stability exhibited a decline. The reduction in stability beyond the peak can be attributed to a corresponding increase in oil in mineral aggregates surpassing threshold of 25%. Then this observer trend suggests a critical point where the positive impact of recycled asphalt pavement content on Marshall stability begins to diminish, potentially influenced by the factors such as aggregate weights. Then figure 3 shows effect of percentage rep on the flow. Figure 3 indicates that as a percentage of recycled asphalt pavement increases, the flow value decreases as it is influenced by several factors associated with the characteristic of rep. The presence of rep may increase the air voids within the mix. Higher air voids can lead to reduced flowability as there is less asphalt binder available to provide lubrication between particles. Moreover, wrap materials have usually undergone some degree of aging during their previous use. This aging process can result in stiffer asphalt binder, leading to reduction in flowability. Conclusion: the study looked at how changing the percentage of wrap in asphalt mixture affects its properties. Using local sensitivity analysis, the factors examined included how easily the mixing viscosity, the percentage of recycled asphalt pavement, the total binder, and the percentage of new or virgin binder. The results showed that carefully adjusting the wrap content, aimed for around 25%, can significantly improve the strength of asphalt concrete mix. This suggests that by smartly managing the use of recycled material, we can make better, construct more durable roads, contributing the sustainable construction practices. The study also emphasized how different factors work together to influence the characteristic of asphalt, providing useful information for those working in the arena of asphalt. Then the sum of the references at have made for my work. This was the slide. And thank you.